material removal by traditional machining operations have always been the workhorse of manufacturing industry. Because of following reasons. It gives good dimensional tolerances. It is cost effective. And they have got high productivity. During an orthogonal cutting, material is removed from the workpiece with help of cutting force. Along with that, a thrust force, which is normal to cutting direction, is also induced. The thrust force could be either upward or downward. If you take a close look at cutting operation, it will be evident that material is getting removed from workpiece by shearing action, where different layers of atoms slip one another to form chip. This is why there is a change in chip thickness from uncut to cut chip. In actual case, the shearing mechanism happens in a region called shear zone. But analysis of such a case will be too complex for this lecture. So, we will assume, instead of zone, the shearing happens in a single plane. This is known as shear plane theory. According to this theory, material from uncut region undergoes a sudden shear transformation across this plane. As you can see here, thin layers of material slip across this plane. If you know orientation of this plane or shear angle, you can easily predict chip thickness using some trigonometric analyses. But, what is the orientation of this plane? That is the big question in machining and analyses. It could be at any angle during a particular machining operation, as explained in these figures. As shear angle decreases, thickness of the chip increases. One way to predict the shear angle is, assume shear plane adjust itself to reduce energy required for cutting operation. Or, shearing will take place in a plane where there is maximum shear stress, so that force and work required for cutting is minimum. Shear stress at an angle phi is given by this equation. By differentiating this equation with respect to phi and setting it to 0, one can obtain the plane on which shear stress is maximum, as this, where beta is the friction angle between tool and workpiece interface. Pretty simple equation to predict shear angle. This is known as merchant analysis. Even the result given by merchant analysis does not always match with experimental results, this is a fairly good assumption. There are various other models also available to do this. Since material flow before and after cutting operation is same, we can write. This is assuming width of the material does not increase much during machining. For analyzing cutting force in a machining operation, you can refer to this video. Thank you.